All right. Okay, we'll start. Good evening. And I'm audible, right? Good evening. All right. Okay, audible. Right? Okay, we'll start. Right. So today we are with day 14 of S2 discussions we had. Right. Today is the day 14, and today I thought of discussing some questions from Ohm's law. Right. Ohm's law and equivalent resistance. Ohm's law and equivalent resistance. And sooner I'll be starting structural essays and essay questions also in S2 discussions, right? So this week also I waited before starting structured essays from electricity because meter bridge is not yet covered in the classroom, right? That's why potentiometer is done, but still I didn't cover the meter bridge. So this week I'll be doing the meter bridge. Then after that, I will take some structural essays also, right? And not only from electricity, right? So we'll be doing some structural essays targeting what is to come this time, right? Targeting what is to come, which experiments to come this time. By targeting, we'll do something, right? And I have thoughts in mind to take some essays also, essay questions also to the discussion, right? So if you have got the questions, so I think you have tried, right? If you haven't got the questions yet, a message is pinned on the live chat, right? There's a message that is pinned on the live chat, so you can just go there and through that link download the questions and try them, and you can hear the reviews here, right? Or else in the channels also all the links are put in the channels, and here also they are, I think in the description also that's there. All right, then without any further ado, we'll start. Let me share my screen. Let me share the screen. Right. All right. So quickly, if I recall what is to be known in Ohm's law, right? What we knew and what we know, and what is to be known is simply a equation of Ohm's law is delta V equals IR, right? Man quickly theoretically recall karana, right? Tagala padang kana kalin theoretically recall kala padang delta V equals IR, right? Delta V equals IR, where delta V is potential difference, I electric current, R is resistance, right? And other than that, equivalent resistance, we know if resistors are in series combination, say R1, R2, and R3, when they are in series combination, this equivalent resistance is given by R1 plus R2 plus R3, right? If resistors are in parallel combination like this, say R1, R2, and R3, right? 1 over R equivalent is given by 1 over R1 plus 1 over R2 plus 1 over R3, right? About equivalence. And then we might need potential divider, right? Potential divider is if we know a total potential, across a system of two series resistors, say V, and resistors R1 and R2, right? V1 can be written as total over addition R1 plus R2 if we need potential difference across R1 into R1, right? If you need potential difference across R2, right? This is VO R1 plus R2 into R2 potential divider, right? Yeah, basically these are the things we should know before starting, right? Then I think it's clear. We'll start, right? Okay, first one. Three equal resistors, 12 ohms, each are provided. What is the value of the resistance that cannot be obtained from one or more of them in combination? Right. Equivalent resistance. When resistors are connected in combinations, right? Equivalent resistance combinations, always the maximum possible resistance is when all resistors are in series combination. Minimum possible resistance is when all resistors are in parallel combination. Simple as that. Then if there are three 12 ohm resistors, right? When all three are in series combination, this is how it looks. 12 ohms, 12 ohms and 12 ohms. Then here the equivalent is 12 plus 12 plus 12 means 36 ohms, right? If all three are in parallel combination, right? 12, 12 and 12, right? It is going to be 4 because 1 over R equals 1 over 12 plus 1 over 12 plus 1 over 12. Then 1 over R equals 12 over 3. We need RE. RE is 12 over 3, 4 ohms, right? So simply, when all resistors are in series combination, we have the maximum value. Then this is the maximum. When all resistors are in parallel combination, we have the minimum value. Any value in between this minimum and maximum is possible. Right? If the value is out of this range, that is not possible. Right? So we have 2 ohms here. 2 ohms is not possible to obtain from this. 2 ohms is not possible to obtain from this. Right? So we discussed these things in the class also. When resistors are in series combination, always resistance is maximized, right? Since resistance is maximized, then maximum equivalent is when all resistors are in series combination. When resistors are in parallel combination, always resistance is minimized, right? It decreases, minimized. Then minimum resistance is when all three are in parallel combination, right? Second one, the effective resistance between the points A and B of the network shown. Effective resistance, right? So we know if same current flows through resistors, that is a series combination. If resistor is connected between same points, in other words, same potential difference, they are parallel combinations, right? Now, if I think of a current flow from here, 3 ohms, this same current is going to flow through the other 3 ohms as well, which means these two 3 ohms are in a series combination, right? These two 3 ohms are in a series combination. Right? So at once I'm going to simplify this. See, now after erasing this, see, at once I'm going to simplify this. Right? Look at here. At once I'm going to simplify this. Then 3 and 3 means 6. Series, no? 3 plus 6. Then this equivalent is 6 between these 2 points. Then simplified 6 ohms with the given 6 ohms, 6 and 6, equivalent is 3 again. Parallel, no? 6 and 6 means 3 again. 3. Then again, another simplified 3 here with this 3 and 3, 6. Series combination. Again, that simplified 6 with this 6, 6 and 6, parallel, 3. 6 and 6 parallel, again 3. Right? That 3 again with this 3 and 3, 6. Right? See, very simple. 3 and 3, 6. Again, 6 and this 6, parallel, 3 again. Right? Then again, finally, 3 and 3, 6, and again 6 and 6, 3 again. That is 3 ohms. Right? Clearly, hadanna yanna epa. Simplify වෙන values නම් ටක් ගාලා හදන්න ආයි ලියලේ ඉන්නත් ඕනේ නැහැ. right? ලියලේ ඉන්න ඕනෙත් නෑ ලියලේ ඉන්නත් එපා ඉතින්. right? Simplify වෙන values නේ ටක් ගාලා හදන්න පුළුවන්. right? Start from one end and simplify the circuit. Right? right? On simplification kalla venna, but make MCQ work nisa, you should be able to simplify this faster, right? Simplification kalla venna. 3 ohms, 3 ohms, 6 ohms, 3 ohms, 6 ohms, 6 ohms, 6 ohms, 3 ohms, 3 ohms. A and B, right? See, 3, 3, 6, 3, 6, 3, 6, 3, 6. Right, see, I'm going to simplify one by one. These two are series, no? 3 and 3. Then these two are going to be replaced by a single 6, like this. A single 6. Then these two are replaced. These two are replaced now. These two are replaced. Right, make an circuit. Then 6 and 6. These two are parallel. Right? 6 and 6 again. These two are two parallel resistors now. These two are two parallel resistors now. Parallel. Then 6 and 6. 1 over 6 plus 1 over 6 is 2 over 6. 6 over 2 is 3. Right? Then that is going to replace by a single 3. Then I make a replace a single 3 again. See? Then this can be replaced by a single. This can be replaced by a single 3 here again. Right? Then again, this 3 to this 3 in a series combination. Then these two can be replaced by another single 6. Now this part is simplified. This part is simplified now. Right? Now again, 6 and 6 remains here parallel 3 ohms. So we can erase these two and replace this with a 3 ohm. Right? Then you can replace this with a 3 ohm. Right? Again, this 3 ohms to 3 ohms series. Right? 3 and 3 series. Then 3 and 3 means 6 again. Then again a 6 ohm here. Right? This is simplified now. Right? Again, 6 and 6 parallel. Oh, sorry. Again, 6 and 6. Again, 6 and 6 parallel 3 ohms. Then finally, we can erase this part and replace this with a single 3 ohms. Replace this with a single 3 ohms. Right? So again, 3 and 3 in a series combination, 6. Then that 6 with this 6, 3 ohms. So final answer is 3 ohms. That's how I got 3 ohms. That's how I got 3 ohms. Right? Start from a simplifiable point. Start from a simplifiable point and proceed. Start from a simplifiable point and proceed. Right? That's it. Next. Third one. In the circuit shown, XY is a rheostat. What is a rheostat? Rheostat is a variable resistor. Variable resistor. Right? Variable resistor. We discuss about rheostat in potentiometer also. Rheostat, whose center is Earth. When the slider SC is moved through the entire length of the resistor from X to Y. Right? This is about this. Is slider is moved from X to Y. Slider is moved from X to Y. Slider is moved from X to Y. X to Y, which of the following will best represent the variation of the potential VA at A with respect to Earth? Right. VA. VA. So we know if current flows in this circuit like this, say a current I flows, this is how the current flows. So after this point, it will divide. Now, using this current, we can write potential at A. No? See, starting from VA. Starting from VA towards the direction of current, we know minus IR. Then minus IR naught. Right? Then other side is, now we add the ground in. The other side is the ground in. No? We add the ground in. That is 0. Then simply VA equals IR naught. VA equals IR naught in this circuit. VA equals IR naught. Right? Now, when you try this type of a question, it is always easier to check endpoints first. Right? Check the endpoint first. Endpoints first. Right? Abhi X will come when at X. At X. Right? When this is at X, current is going to pass by the wire like this. Then it is going to skip the rheostat. skipping rheostat means rheostat is shorted. Rheostat is shorted, short circuit. If rheostat is shorted, resistance of rheostat is not in the circuit anymore. Right? We know when resistance decreases, I increases. No, when resistance decreases, I increases. When resistance decreases, I increases, because always I and R are inverse in electricity. I and R are inverse in electricity. Right? Which means when I increases, VA increases. Right? So one idea is that at X, VA should be at a maximum point. Right? Then VA should be at a maximum point at X. Right? VA should be at a maximum point at X. Right? Then again, if we check at Y, similarly, at Y, now when this is connected to here, when the slider is connected to here, current passes through the slider again from this side, again it skips rheostat, which means rheostat is going to be shorted. Again, rheostat is shorted. If rheostat is shorted, again the same thing. At Y also, rheostat is shorted, no? Right? Rheostat is shorted. Then at Y also, when R decreases, I of the circuit increases. When I increases, VA becomes max. Then at both X and Y, there should be maximums. At both X and Y, there should be maximums. Right? So that's how we check this. At both X and Y, there should be maximums. At X and Y. Right? In between, no need to check. In between, resistance of rheostat is there is non-zero. In between, resistance of rheostat is non-zero. In between X and Y, resistance of rheostat is non-zero. Since resistance of rheostat is non-zero, when resistance increases compared to this scenario, I decreases. When I decreases, right? When resistance of circuit increases, I decreases. When I decreases, we know VA decreases according to this equation. VA decreases. Then, which means there should be two maximum points at the ends. And in between, it decreases, right? It decreases. That's enough. That's enough. Having that is enough. But that is not zero at the midpoint even. That is not zero. That is not zero. VA is not zero because even at the midpoint current passes. Even at the midpoint current passes. Then only possible answer is 3. Endpoint should be maximums, and in between that is less. Right? Tie is between 2 and 3. No? It is never going to be 0. It is never going to be 0. It is never going to be 0. Right? That's a logical question. A logical question. You have to think a little bit logically. You have to argue a little bit logically. Right? Logical arguments. Right? Take down if anything. Take down if anything. Right? Okay. Next. Question 4. A normal 3-pin plug top, the earth pin is thicker than the other 2 pins. This is because, right? So about this, we discussed in the theory class also, right? The reason of wires being thick, the reason behind wires being thick, right? Is the reason again. R equals rho L over A. R equals rho L over A, right? R equals rho L over A. When a wire is short and thick, when a wire is short and thick, its resistance decreases, right? Comparatively lesser. Resistance of the wire is comparatively lesser, right? Then when resistance decreases, we know I increases. No? When resistance decreases, I increases. Then when a wire is short and thick, when a wire is short and thick, listen, when a wire is short and thick, it is able to, or it is capable of carrying a higher current, right? It is capable of carrying a higher current. That's the point behind. When the wire is thick, it is capable of carrying a higher current, right? It is capable of carrying a higher current, right? That's the point. Then through the earth, to pass a higher current, it is thick, right? Higher current then through the earth terminal, to pass a higher current, right? Because overload to pass a higher current, that is thick. Then what's it? The earth pin should have a higher resistance. No, it's a lower resistance. The earth pin should have a higher thermal capacity. No, thermal capacity depends on the substance. The earth pin opens. The earth pin opens. Gates to the other two pins. No, it is earth first. No, to provide the low resistance to the earth line. 5. Low resistance means higher current. Low resistance, higher current. Low resistance, higher current. Right? 5. In the circuit shown, P is a variable resistor, Q is a fixed resistor, and the cell has a negligible internal resistance. A is an ammeter and V is voltmeter. As the resistance of P is increased, the reading of, okay, when P increases, right, listen. Right, first thing I see is, now, if this point is X and if this is Y, right, this is also X, this is also X, this is Y, right, which means potential difference across V is, right, Vxy, that is equivalent to EMF of the battery from here equivalent to E. If the battery is unchanged, voltmeter reading is unchanged. If the battery is unchanged, voltmeter reading is going to be unchanged, right? Voltmeter reading is going to be unchanged. That is one thing. That is one thing, right? Then about current, then we know current passes in this loop. No, current passes in this loop, right? For this loop, if you use an equation like sigma equals sigma R, right? Sigma is E, right? Passes current is I, let's say. Then resistors are P and Q. Resistors of P, resistance of Q, right? See what happens for current. I is E over RP plus RQ. Now it says RP increases. RP increase right? P is a variable resistor. P is increased, right? When RP increases, I decreases, which means ammeter reading decreases. I decreases, which means ammeter reading decreases. So that's it. Ammeter reading decreases and voltmeter reading remains unchanged. Ammeter reading decreases and V remains unchanged. It's 4. Right? See how these our known things are used, right? All are known logics, known things, known theories, right? So that's how it is used. 6. Equivalent. 12 equal resistors, each of resistance R are joined from the network shown in the figure. The effective resistance between the points A and B equal to, right? So we have discussed around 9 techniques of simplifying equivalent resistance, right? We have discussed around 9 techniques of simplifying equivalent resistance, right? Then from the 9 techniques we had, now you should be able to think of what is to be applicable here, what is to be applied here, what is applicable here, right? So that thinking is on us, right? Now since from A to B, since all the currents are divisible, right? I'm going to go with the current. Right? Let's say incoming current is 6I, at A to the circuit, 6I. Then along these 3 identical paths, current is going to be divided, right? As 2I, and 2I, right? And again, these two are identical in terms of resistance. then it is divided as I and I. Right? This I comes up to here, and this I comes up to here. Here also we have I and I, right? Then through this it's altogether 2I, and this is also divided as I and I. This is I, so it comes all the way, it goes all the way to here, right? Then I means this is 2I, right? Then I and I here is 2I in this line. Then from B, 6I goes out. Currents are done. Currents are done. If currents are marked, we know we can equalize potential differences. If currents are done, we can equalize potential differences. Let's assume this as the equivalent resistor between A and B. Say that is Re. Then the current should flow through this is also 6I. Equivalent is the single one to replace the system. Then current flow through this should also be 6I. Right? Then we know from either side, from either circuit, VAB equals VAB. From either of the circuit, VAB equals VAB. Right? To write VAB from this first circuit, right? We know when a resistor functions, IR amount of voltage is potentially is absorbed, right? Then from A to here, 2IR is absorbed. From here, IR is absorbed. And from here, 2IR is absorbed. Then total potential absorption is 2IR plus IR plus 2IR. Right? And VAB from the equivalent circuit is IR, I is 6I, RE. Right? Simplify. Then 2IR, IR, 2IR means 5IR. 5IR equals 6I, RE. 5R equals 6I, RE. I2, I cancels. Right? So RE is coming as 5R06. Final answer, 5R06. Right? Take down if anything. Take down if anything. Right? Next. Right. Next. 7. Right. Ask if any questions, ask if there's anything to clarify. Ask if there's anything to clarify. Right, 7. Two conductors A and B of uniform cross section N made of the same material have equal volumes. If the areas of cross section of A is 4 times that of B and the resistance of A is 2 ohms, the resistance of B is. Okay. See, two conductors A and B, right? Say A and B, right? Two conductors A and B. අඳින්න ඕනේ නැහැ මම මේ idea එකක් එන තමයි අඳින්නේ. Right? You don't need to draw the conductor when you do the question, right? I'm drawing to you to get more idea, have more idea, right? Right, A and B. මෙහෙමනේ තියෙන්නේ. Made of same material. If made of same material, resistivities are equal. Rho and rho. Equal volumes, right? Volumes are equal, it is given. And the cross-sectional area of A is 4 times that of B. Then if this is A, this can be written as 4A, right? We have no idea about length, right? Then let's consider as this length as LA and this length as LB. Right. Now, since volumes are equal, first we can build up something. V equals V. Right. Volumes are equal. Then from A, that is 4A times LA. No? From B, A times LB. A to A cancels. Right. We have something here. 4LA equals LB. One result. 4LA equals LB. Right. Now, something about resistance is asked. Right. So, we know resistance is rho L over A. No? Resistance is rho L over A. Resistance is rho L over A. Resistance is rho L over A. Right. Now, if we apply this for A, it says 2 ohms. 2 ohms. Rho is rho. L is LA. LA. Right. Over 4A. No? Right. Equation. Now, from this, I can get something like this. 8 equals rho LA over A. 8 equals rho LA over A. Right. Now, if I do the same for B, right, then R of B equals same rho, but LB over A. No? Right. Now, about length of B, we have something. See, about length of B, we have something. About length of B. For LB, we can use 4LA. No? Then RB equals rho times for LB, we can use 4LA over A. Right? Then if you take this 4 aside, rho LA over A, rho LA over A is 8 from here. Rho LA over A is 8 from here. Then final answer is 32. 32 ohms. Right? See how creatively the question is asked. Right? Apply two equations and then either you can divide the equations or you can plug as I did. Anything is fine. Up to you. Anything is fine. Right? Take it down. Right, let's move on. Next, a battery of negligible internal resistance and EMF V is connected as shown. The potential difference across A and B is right. Potential difference across A and B. Potential difference across A and B. Right. Say that is V. Potential difference across A and B is, let's say, V. Right. Now, this is how current flows in this given circuit. Right. This is how current flows. Right. There will be a current comes to here and it is divided at this point, and the same current is going to flow through these two. Same current is going to flow through these two. Right. If same current flows through resistors, they are in series combination. They are in series combination, which means I can simplify this given circuit as right. This is RR. RR means 2R. Then this given R is here. This given R is here. This is simplified to 2R. This is simplified to 2R. Simplified to 2R. Right. Then again, these two are parallel. Can simplify. Right. Then 1 over R plus 1 over 2R. Right. This is about 1 over R. No? Then R dash is 2R over 3. Right. Then finally, we have these two resistors in the circuit now. This is simplified to 2R over 3. This battery is E. This is R. This is simplified to 2R over 3. 2R over 3. Right. Which means we can find the potential difference across these 2 points. First, right, let's say that is V dash, right, potential divider, V dash equals, right, these two are two series resistors, no? Then apply potential divider, V dash equals, total is E, over addition R plus 2R over 3 times 2R over 3 times 2R over 3. Right? Then simplify this. Common denominator is 3 here. Then E over 3R plus 2R again 5R over 3 times 2R over 3. 3 to 3 cancels. R to R cancels. Then it is 2E over 5. Right? V dash is 2E over 5. V dash is 2E over 5. Right? Which means potential difference of this circuit here is 2E over 5. Potential difference of the circuit here is 2E over 5. Potential difference here is 2E over 5. Right? Now, no need to do a further calculation. Again, simply, easily, we can argue this way. Now, this resistance, this potential is divided between these two equal resistors. No? This potential is divided between these two equal resistors. If resistors are equal, right? If resistors are equal, which means potentials are equal because they are two resistors in series combination. In series combination, current is equal. Right now, resistances are also equal. That is given, which means potential differences should be equal. Then this 2E over 5 is going to be divided equally between these two. Right? 2E over 5 is going to be divided equally between these two, which means it is going to be E over 5. 2E over 5 is divided equally E over 5. E over 5. Right? A question from potential divider. Right? You can do the same after finding currents using Ohm's law. So applying Kirchhoff's laws, but it is lengthier, right? So don't go with that option. It is lengthy. It is lengthy. Right? Easiest way is potential divider, like this. 8. Next. 9. 9. Right. 10 resistors, each of resistance 1 ohm, are connected to form a closed loop ABCD as shown. A cell of EMF 10 volts is connected between A and C. If the cell has a negligible internal resistance, the potential difference between D and B is right. Then first thing, to write potential differences, we need to know currents, right? To write potential difference along the circuit, as the first thing, we should know currents, right? Then I'm going to find these currents. If I apply Kirchhoff's laws for this loop above, right? Ithin දාන්නත් පුළුවන් 10 equals 1 2 3 4 5 5i 10 equals 5i එහෙම නෙන්නේ right නිකන් දාන්නත් පුළුවන් sigma E equals sigma ER then 10 equals if current flow is I, resistance is 5, total resistance, right? That is 2 amperes, right? Which means current flow here in this circuit, this part is the direction, that is 2 amperes. Similarly, we can apply for this loop as well, right? It is also 10 equals 5 I know 2 amperes, but the direction is this, because current flows out from the battery, positive terminal of the battery, then these currents flow in this direction, that is also 2 amperes, right? Now, since all currents are known, we can write the potential along the circuit. Since currents are known, we can write the potential along the circuit. Start from D, VD, right? Crossing the resistors to the same direction of current, minus IR, then minus 2 into, there are 3 resistors, 1 plus 1, minus IR, minus IR, minus IR. 3 resistors of 1 ohms, right? And here, from here, you are going to the opposite direction of current. Opposite direction of current means plus IR, then plus 2, right? Plus 2. There are 2 resistors, 1 plus 1. Finally, we add B. Right? Simplify this. Then VD minus 6. This is plus 4 equals VB. We need VDB. Potential difference between D and B is VDB. VDB equals, VDB means VD minus VB. VDB means VD minus VB. Then VD minus VB equals 2. Right? That is called VDB. VDB is 2 volts. Right? So that is 2 volts. 2 volts. right? Writing potentials along the circuits, right? We discussed on the second day. We discussed on the second day of electricity. Writing potential differences along the circuit, right? Take it down. Take it down. Right. How did you take R equals 5? Series combination. Series combination in the loop, right? There are 5 1 ohm resistors in the series combination, right? 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, right? In this above loop, right? Clear, right? Okay. Next. 4 resistors are arranged to form a square as shown in the figure. The resistance of the square is maximum across. Okay. P, Q, QR, points right. I think we can check it one by one. Say P and Q. If you are finding resistance between P and Q, if you are finding the resistance between P and Q, then these three becomes series. These three become series, right? Then 4, 3, 2 means 4, 3, 2, 7, 9. This is 5. Then that 9 to this 5 is parallel. Then between P and S, 1 over R PQ is 1 over 5 plus 1 over 9. Right? You can simplify කළ බැලුවොත් 9 නේද ආවේ? ඔව්නේ. හරිනේ. 1 over 5 plus 1 over 9. Right? That is 14 here, 14, 45. Something like this. Right? This is 1 over R. So R is 45 over 14. Right? So likewise, I'm going to check this across each ends. Right? I'm going to check this across each ends. Right? Now, since this is not clear, I'm going to erase these things and simplify at once. See? Right. Then between Q and R. Between Q and R means these three are going to be series. Right? Then 1 over R QR කියලා කියන්නේ 1 over 4 plus 3 plus 2 plus 5 කියලා කියන්නේ 10. Right? Then that is going to be 14, 40, then 40 over 40. 40 over 40. Right? Then RS is 1 over 3. Right? Within RS 1 over RS 1 over 3 plus RS 1 over 3 plus 2 plus 5 plus 4 කියලා කියන්නේ 7 11. Then 1 over 11. Right? That is 14 33. Right? ඒ කියන්නේ 33 over 14. 33 over 14. Right? PNS right? 1 over 2 plus, right? 1 over 2 plus PS 5 plus 4 plus 3, 5 plus 4 plus 3, 12. Right? That is 24 14. That is 24 over 14. That is 24 over 14. 24 over 14. See? 24 over 14. And last one, QNS. QNS. Right, these two ends. QNS. Then 1 over QNS. From this side, these two are simplifying 1 over 7. Plus from the other side, 5 and 2 kilo again 107, right? So this is 49, 14, then that is 49, no 14, right? Now these are the final resistance values, no? Now easily we can compare, right? That is a common denominator. 45 over 14, 40 over 14, 33 over 14, 24 over 14, 49 over 14. Highest out of all is 49 over 14. Right, then answer is given as 49 over 14. Right, 49 over 14. Right, just a matter of finding these potentials. I make a note at anything. Diagonal at the diagonal check around lazy. Right? When you check the diagonal first, that's easy. Because when the resistance from both sides, 7 and 7, right? When it is higher, the equivalent is going to be higher. Right. 11. 12 resistors of 1 ohm each connected as shown in the figure. The equivalent resistance of across XY is, right? Now from 9 different techniques we discuss about equivalent resistance, right? So at once we can see this is a symmetric circuit. This is a symmetric circuit. The symmetric line here is this one, right? Then resistors on the symmetric line are going to be removed. Resistance on the symmetric line are going to be removed, right? Now if I draw a second circuit between X and Y, right? If I draw a second circuit between X and Y, after removing these resistors, right? Here 1 and 1 is going to be 2 ohms. 1 and 1 is 2 ohms. And here again 1 and 1 is going to be 2 ohms, right? I'm going to simplify this one at once. Look at here. This 1 ohms means series 2. 1 means series 2. 2 and 2 is 1. 2 and 2 here 1. Then 1 and 1 and 1 means 3. Then it is going to be 3 ohms here. 3 ohms here. Right? Now all three are in a series, in a parallel combination. So simplify these three parallelly. So before simplifying parallelly, I can see these 2 ohm and 2 ohm are parallel. No, 2 means 1. Then finally what I need to write is 1 over Rxy equals, right? 2 is 1, 1 over 1 plus 1 over 3. 1 over 1 plus 1 over 3. Then 3 here, this is 3 plus 1, right? Then the reciprocal is 3 over 4, right? 3 over 4, then 3 over 4 ohms, right? That's not a big question. Symmetricness, right? That is from symmetricness, right? Take down if anything. Right, finished. Next. 12. Which of the following current I, potential difference V, curves obeys Ohm's law? Right? That's simple. Right? Ohm's law. Delta V equals IR. Right? So potential difference is given as V equals IR. Right? I is in Y axis. So I is 1 over R V. Right? See? V is X, 1 over R is gradient. This is Y. Right? Ohm's law is Y equals mx. Ohm's law follows the Y equals mx shape. Ohm's law follows Y equals mx shape. Y equals mx. Then That is only A. That is only A. Only y equals mx given here is A. Right? Next. 13. The light bulbs in the circuit shown are identical. The bulb which gives the most light and the one which gives the least light. Right. Simply, light is determined by brightness, no? Right? Light. Light means brightness. Brightness. Right? That is also called intensity. Intensity. Right? That is determined by current. That is determined by current. Higher the current, higher the brightness. Lesser the current, lesser the brightness. Simple as that. Right. Now, I'm going to divide currents here in the circuit. See, it says they are identical ones. Identical. Identical means their resistors are equal. No? Their resistors are equal. Resistances are equal. Right? Resistances are equal. Then, if you try to divide currents here, let's say main current comes from here is I1, right? Then it comes up to here, I1. And at this point, this current is divided. This current is divided. Then only a part of I1 is here. It is divided, no? It is divided. And at this point again, this current is also divided. This current is also divided. Right? That is also divided. Then in terms of currents, this current should be the maximum current because that is the main current in the circuit. That is the main current in the circuit, not divided. That is the main current in the circuit. And after dividing the currents here, this is divided again. Then these two currents are the minimum currents. Let me use a different color. These two currents are the minimum currents. Right? Values same one MCQ. These two are the minimum currents. Right? They are the minimum. And this is the maximum. Right? Then then maximum current is here. Since maximum current is here, maximum intensity is with A. Maximum intensity is with A. Maximum brightness is with A. And the least current, minimum current is here. It draws across D and E. Then both D and E are the minimum brightness. Both D and E are the minimum brightness. Then it should be either A and D or A and E. Right? Only A and D is given in the answers. So it is A and D. Only A and D is given in the answers. So it's A and D. It's A and D. Right? A and D. Right. Next. 14. Which of the following IV curves for a filament electric bulb? Right? Filament bulbs. Filament bulbs. So what happens in a filament bulb is, we know, listen, what happens in a filament bulb is, when filament bulb is turned on for some time, when a filament bulb is turned on for some time, when a filament bulb is turned on for some time, right, heat increases, right, heat increases, that's the impact, heat increases, right, heat increases. When heat increases, listen, when heat increases, right, when this is turned on for a longer time, over time, heat increases, right? When heat increases, resistance increases because we know R theta equals R naught 1 plus alpha theta. When temperature increases, resistance increases, right? When resistance increases, current decreases, right? So current is trying to decrease from the ohmic variation, Ohm's law variation, right? When this is heated, right? That is going to deviate from Ohm's law, and current is going to decrease. Current is going to deviate in the decreasing side, right? Then if this follows Ohm's law, this is what we get now. If this follows Ohm's law, this is the graph you get. Linear. Ohm's law. Now, when it is deviating from I is going to decrease. I is going to decrease. Then from this supposed variation, I is decreasing like this. I is decreasing like this. So simply graph bends towards V. Graph bends towards V. Okay, my point again. That graph bends towards V, right? Only graph given here bends towards V is 4, right? So it is 4. It is 4, right? It is 4. Right? They are called non-ohmic variations. Non-ohmic. Right? Non-ohmic. It deviates from Ohm's law when temperature increases. The reason is resistance. For Ohm's law, resistance must be a constant. Right? Ohm's law is stated when other conditions are constant. Right? So the main condition there is resistance. If resistance is changing, we can't use Ohm's law again. If resistance is changing. Right? If resistance is changing, you can't use Ohm's law again. Right? 15. Which of the following is more suitable when connecting electrical components in laboratory experiment setup? When you use laboratory experiments, and in the theory class also I told you the same, right? Always we focus on the capability of carrying a higher current. We focus on the capability of carrying a higher current. To carry a higher current, right? Resistance should be low, right? Resistance should be low. To carry a higher current, resistance R should be low, right? R is low in short thick wires because R is throw a low wave, right? When a wire is short and thick, resistance is low. When a wire is short and thick, resistance is low, right? Then always short thick wires are used, right? It should be short and thick. Short thick wires are used, right? Then thick short wires are used. Thick short wires are used, right? Right, take it down. I'll be back quickly. Okay. Right. Am I audible again? Next. Right. Next one. 16. 16. The three graphs ABC show variations in electrical resistivity, rho with temperature. This is completely from theories. Completely from theories. Right? First day variations, right? We know four variations, right? We know four variations about resistance and resistivity of a conductor with temperature, and resistance and resistivity of a semiconductor with temperature, and resistance and resistivity of insulator with temperature, and finally resistance and resistivity of a superconductor with temperature, right? Then this is a conductor, make a theory part. This is a semiconductor, right? And this is a superconductor. Then first one should be a conductor, metallic conductor, right? Second one semi, third one super, then second one, right? It's a theory question. It's a theory question. Theory question, right? Then 17. An underground cable of length 4 kilometers. Underground cable of length 4 kilometers consisting a pair of identical conducting wires has short somewhere along its length as shown in the figure, right? A person detects that the resistance across AB and CD are 30 ohms and 70 ohms, right? Resistance across here 30 ohms and resistance across here is 70 ohms. 70 ohms, right? Respectively, the distance to the shorted position from A is distance to shorted position from A is, right? We know R equals rho L over A, R equals rho L over A, right? If same material, same substance is used, rho is a constant, right? Now they are identical conducting wires. Identical conducting wires means A is also constant. So simply R is going to be proportional to L. R is proportional to L. R is proportional to L. Then resistance at this side is proportional to the length here, and resistance of the other side is proportional to the length there, right? Then simply I'm going to apply this for these two, right? Then 30 should be proportional to, we need distance from the distance to shorter point from A is, right? Then let's assume this as X. This is what we need, X. If there is X, this is 4 minus X. If there is X from the other side, that should be 4 minus X from the other side, right? Then 30 proportional to length X, and from the other side 70 proportional to its length is 4 minus X, right? Simple. Divide these two, right? If you understood the question properly, there's nothing to do there, right? Simplify. 30 over 70. 30 over 70 equals X over 4 minus 6, right? These two cancels. Simplify. 12 minus 3x equals 7x, right? 12 equals 10x. X equals 1.2 kilometers. X is 1.2, right? Another different aspect of the same theory is we know. Same theory. But question is asked from a different angle. Right? Take it down. Right. Next. 18. The ratio V over V out, V naught, the ratio VO V naught for the given voltage divider circuit is equal to. Right. Now, I'm going to simplify this voltage divider and going to find the find the potential of each part. See, now easily we can divide this here. No, we can simplify this here. No, see, हम एक बार simplify करना. This is RR, that is 2R. No, then that 2R and this R are parallel. Then 1 over R plus 1 over 2R, that is 2R over 3. No, that is 2R over 3. Then finally in this circuit, this is what is remaining. R here, and after the simplification, 2R over 3 here, after the simplification. This is given as V naught. This is given as V naught. This is given as V naught. Right, then if there are two resistors in series combination, we can at once find the potential across this one using potential divider. Right, then potential across this one is, say that is V dash, total is V naught over addition R plus 2R over 3, R plus 2R over 3 into required resistor 2R over 3. Right, simplify this. Then it says 2V naught over 5. Right, 2V naught over 5. V dash is 2V naught over 5. If V dash is 2V naught over 5, then this should be 2V naught over 5. Right, මේකනේ මෙතන තියෙන point 2V naught over 5. Right, now again this is also similar question as what we did before. කලිනුත් මේ જાතිය එකක් හදුවා. potential divider එකෙන් මම හදුවේ මේ answer එකමයි ආවේ. මේකෙත් එන්නේත් ඒ answer එකමයි. Right, 2V naught over 5. 2V naught over 5. Now these two are two equal resistors with, listen, these two are two equal resistors with in a series combination. No, then it is divided equally. Then this is going to be V naught over 5. I divide කර කර ඉන්න එපා. Right, ඕනෙම නම් දාලා බලන්න පුළුවන් potential divider එකක්, but no need. Right, මේක ඕනනම් V double dash total across these two resistors, total across these two is 2V naught over 5. No, 2V naught over 5. 2V naught over 5. See, total across these two is 2V naught over 5 over addition R plus R into R. Then it is 2 cancels V naught over 5. That is V naught over 5. Right, which means this is between the same points. Then V equals V naught over 5. Then therefore V equals V naught over 5. We need V over V naught. V over V naught is 1 over 5. V over V naught is 1 over 5. 1 over 5. Right, again potential divider. Potential divider. Right, potential divider is very popularly used when it comes to our questions here. Right, very popular. Next. Right, let's move on. 19. A uniform wire is cut into 3 equal pieces, A, B, C. Right. If it is cut into 3 equal pieces, their resistances are given, they are going to be equal. Say simple R each, resistances, simple R each, right? They are going to be equal. A, B, C are connected as shown in the figure. If the ammeter A2 reads 1.2 amperes, then the reading of the ammeter A1 will be, right? Then we can do this using currents. Currents කොහොමද තෝරන්නේ? ammeter reading යන දීලා තියෙන්නේ. Then let's try to mark currents here. Let's try to mark current flows here. Let's try to mark current flows here. Right? That's the thing. Let's try to mark current flows here. Listen. Now, since these two are parallel and equal, these currents are equal, no? Connected between same points, same potential difference, and resistors are also same because identical, it says identical pieces, right? Then these currents are equal. Say this current is simple line, then this is also simple line, which means through this part of the circuit, current flow should be 2I, no? through this part of the circuit, current flow should be 2I, right? Now, if I need to find the current flow along this part, let's say X, then what you can do is, we can say these 2 points are equal. If this point is A, right? If this point is A, this is also A. If this is B, this is also B. Then these two resistors can be simplified. R means they are parallel R over 2, right? Then simply what we can do is VAB equals VAB. VAB equals VAB. From the circuit above, resistance is R over 2, no? Then the total current flows through that R over 2 is 2I. That is known. Total current flows through that one is 2I, right? Then from that 2I times R over 2, no? And again VAB can be written using the resistor here, as current is X, resistor is RXR, right? Then 2 cancels, R cancels, it says X equals I, right? Which means this current is also I. Right? Now, the current flow here is I and current flow here is 2I, then total current flows through this should be 3I. Total current flows through this one should be 3I, right? Okay, now I have something because A2 is given, right? Which means 3I equals 1.2, right? Which means I equals 0.4 amperes. I is 0.4. We need A1. A1 is 2I, no? A1 is 2I, then 0.8 amperes, right? See? Now, if you do the things properly, if you do the things properly, right? Simply, the answer comes. Simple as that, right? ටිකක් වෙනස් ගානක් ඉතින්. හොඳයි. පොඩි ගානක් හැබැයි. Take it down. Take it down. Next, 20. All the components shown in the circuit are ideal and the point X is grounded. Okay. If center zero voltmeter V is used to measure the voltages at A and B by connecting its free end to A and B respectively, then the corresponding readings will be, right? That's a center zero voltmeter, right? Center zero voltmeter means always the reading of voltmeter is going to be reading of the positive terminal minus potential at the negative terminal. Potential at the positive terminal minus potential at the negative terminal, right? That's how a center zero voltmeter is giving a reading, right? Okay, then to find potentials, we need the current, no? To find potentials, we need current. Then for this loop here, closed loop here, we can use Kirchhoff's laws. Sigma equals sigma ER. Sigma E is 5 plus 5, 10, right? Only a single current flows, say I, and total resistance in the circuit is 10, 10, 10 plus, 10 plus, 50 plus. Total resistance in the circuit is, see, 10 plus, 10 plus, 50 plus, 20 plus, 10, right? That is 100, no? Then 10 equals I times 100. I is 0.1 amperes. Right now, we can find potentials at A and B. Right? Because it's asked about A and B, right? Yeah. A and B respectively. Okay, potential at A, right? Delta V equals IR දැම්මත් හරි resistor එකට නැත්නම් along the circuit ලියන්නත් පුළුවන්. Right? Either you can use delta V equals IR for the resistor there, or else you can write the potential along the circuit. Either way is fine, right? Then if I use delta V equals IR for 50 ohms, see, delta V equals IR for 50 ohms. Then current flows in this direction. It is important. It is very important, right? Very important. Then VA minus VX. VA minus Vx equals IR. I is 0.1, R is 50, right? But we know Vx is 0 because these are ground in. These are ground in, Vx is 0, right? Which means VA equals 5 volts. VA equals 5 volts, right? Similarly, to find VB for 20 ohms, if you use delta V equals IR, that is Vx minus VB equals I is 0.1, R is 20, Vx is 0, right? Then 0 minus VB equals 2, which means VB equals minus 2 volts. VB equals minus 2. VB equals minus 2, right? Now, readings are asked. Readings are asked. Then, when it is kept at A, right? This terminal is a positive terminal. Positive terminal is going to be at A. Then at A, what happens is potential difference is positive minus negative. Positive is now A, 5. 5 minus 0. 5 minus 0, that is 5 volts. Right? Then if it is kept at B, positive minus negative, positive is at B now. Positive is positive is at B. B is minus 2. Then reading is minus 2 minus 0. That is minus 2 volts. Then 5 minus 2, 5 and minus 2, answer 2. Right? That's a good question again. Right? A good one again. 5 minus 2, answer 2. Right? It's a good one again. Take it down. Now, when it comes to current electricity, when we know all theories properly from the beginning, right? I told you on the first day also, right? When you know all the theories from the beginning, that's very much easy. But if your foundation is not good, then sometimes you might be struggling. So always this is coming with the foundation, right? Basically, all questions are given from Ohm's law and Kirchhoff's laws. All questions are given from Kirchhoff's laws and Ohm's law. Right? Next. #21. VO V naught of the voltage divider shown is, right? Now this is the third time similar type of a question is coming, right? See, that's the importance of doing past papers. That's the importance of doing past papers. This is a third time, similar question, third time, right? Let's see. Okay. VO V naught. See, 2R, these two are parallel. No? Then my requirement is simplify now. 2R, these two are parallel. Then it is going to give R. Then R means 2R here. R means 2R. Then 2R and R means again, for here you are going to get 2R over 3. Right? Or Kalin simplification. Right? Come on, answer again. 2R over 3. Right? Now, if you apply potential divider, right? If you apply potential divider for these 2 points, right? Total is V naught over addition is R plus 2R over 3 times 2R over 3, right? Simplify this. That is 2V naught over 5. 2V naught over 5, right? If there is 2V naught over 5, we know this was R, no? Then R equally divided. Then along this part, it is going to be equally divided, no? V naught over 5. That is V naught over 5. Same question repeats for the third time now, V naught over 5, right? Which means, right, V equals V naught over 5, right? V over V naught, 1 over 5. V over V naught, 1 over 5. Right? Same question. I hope it's clear because that's the same question we did for the third time now. Right? Next. 22. In the circuit shown, V represents an ideal center zero voltmeter. R is a variable resistor, value of which can be varied from 0 to 10,000. As R decreases from 10,000 to 0, voltmeter reading will approximately vary from. Right. Now, let's start when R is at 10,000. Now, first of all, I'm going to find the potential here. Potential here. I need the potential here because we are to write the reading of center zero voltmeter, that is potential at positive terminal minus potential at negative terminal, right? So let's label this as X for my ease and this as Y for my ease, right? Then to find Vx, you can use potential divider for these two, right? Then applying potential divider, this is 0, no? Applying potential divider, Vx minus 0 equals, total is 10 minus 0, 10 minus 0 over addition 750 plus 250 times 250, right? Simplify. Then Vx equals 10 times, this is 1000, 250, right? Then 4. Vx equals 2.5 volts. Vx is known. Vx is 2.5. Vx equals 2.5, right? Then at 10,000 n, at 10,000 and 0, I'm going to do two calculations, right? Now, this is known using these two, right? Then, see, when 10,000, when 10,000 ohms, equivalent here is when 10,000 equivalent is 1 over 100 plus 1 over 10,000, no? Compared to 100, 1 over 10,000 is negligible. Compared to 100, 1 over 10,000 is negligible. Then we can consider the equivalent as 100. We can consider the equivalent as 100. Then these two are 100 and 100. 100 and 100, right? If these two resistors are 100 and 100, right? If these two resistors are equal, right? Potential difference is 10 and 0, 10 volts, no? It is going to be divided equally. It is going to be divided equally. Then 10 is going to be divided equally as 5 volts and 5 volts. 5 volts and 5 volts. Since this point is earth, this point here, Y, should be 5 volts. Y should be 5 volts, right? Since the point here is earth, potential difference is 5 volts, but one point is 0, then Y should be 5 volts. Y should be 5 volts. Now the reading is, right? Reading is plus minus Vx minus Vy. Vx was 2.5, right? And Vy is 5. That is minus 2.5 volts. Minus 2.5. Right? Then do the same at 0. 0 neither. Oh. Do the same at 0. When 0 ohms. Right? When 0, it's like there's no resistor here when it is 0. Right? If there's no resistor here, no need to do any calculation. This is grounded 0, then Y becomes 0, which means Vy equals 0. If there's no resistor, Vy equals 0. Right? If there's no resistor. Right? Sorry, resistor. If there is 0, it is like no resistor here. It is like there's no resistor here. No resistor here. Then if it is 0, Y becomes 0. Y becomes 0. Right? Now the reading is again Vx minus Vy. Right? Vx is 2.5 minus Vy is 0. Right? Then that is 2.5 volts. Minus 2.5 to plus 2.5, it's 3. Minus 2.5 to plus 2.5, it's 3. Right? See how these questions go. Right? Take down if anything. Take down if anything. Next. 23. The equivalent resistance between X and Y in the network of resistances. Right? Simple. Right? So we know if resistors are in this Whitson bridge, if the resistors are in a Whitson bridge between A and B, say R1, R2, R3, and R4, R5, right? So we know if R1 over R2 equals R3 over R4, R4, right? If this is X and Y, then Vx equals Vy. If Vx equals Vy, the resistor here is going to be shorted from the circuit. Resistor here is going to be shorted from the circuit because it doesn't have any potential difference, right? Whitson bridge. මේක තමයි මේකේ theory එක. Whitson bridge. Whitson bridge, right? Okay, so this is also Whitson bridge, right? This given one is also Whitson bridge. Then this resistor is going to cancel, right? Then in the Whitson bridge between X and Y, right, only these resistors remain between X and Y, right? Here R, 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 right? Then R means 2R, R means 2R, 2R, 2R parallel. Final answer is R, right? Simple. Final answer is R. Whitson bridge circuits. Whitson bridge circuits. Whitson bridge circuits. Right? The theory part is Whitson bridge. Theory part is Whitson bridge. One second. Right. 24. 24. 24. Consider the following two circuit diagrams. E1 diagrams, E1 and V2 are voltmeter readings, and I1 and I2 are ammeter readings. If the voltmeters and ammeters are ideal and the internal resistance of the cells are negligible, which of the following is true? Which of the following is true? Right. Right. For first circuit, if we apply Kirchhoff, see, you can get one relationship. If you apply Kirchhoff's laws, you can get one relationship. Then sigma is E, no? Is IR, that is I1R, right? Which means I1 is E over R, no? I1 is E over R, right? We have one relationship. And about V1, easily we can find V1 this way. If this point is X, this is also X, this is also X. If this point is Y, this is also Y, this is also Y. Ideal ammeter means there is no resistance. Ideal means resistance is 0, right? Then we know Vxy equals Vxy. These two are connected between same 2 points, right? From above, Vxy is V1. From below, that is E, right? Simply, V1 equals E. V1 equals E. V1 equals E, right? So I can see the same in the second circuit also. See, if this is X, all these points are X. X. If this is Y, all these points are Y, right? From the second circuit also, we can see the same. From the second circuit also, we can see the same, right? Then what it says is V2 equals E, right? But we know from first one, V1 equals E. What's the meaning? V1 equals V2, right? Therefore, V1 equals V2. V1 equals V2, right? And then we have to check few more things about currents. Now, potentials are checked. V1 equals V2. About currents, right? Let's simplify these two and I'm going to apply a Kirchhoff again at once for the simplified circuit. These two are parallel, no? R. RR means R over 2. R over 2. Then in the circuit, total resistance is going to be R over 2. Right? Apply Kirchhoff's laws. Sigma E is E. Right? Current flow is I2. Resistance is R over 2. Resistance is R over 2. Right? Then what about I2? I2 is 2E over R. Right? Whereas I1 was E over R. Right? I2 is 2E over R. Right? Then I2 is greater than I1. I2 is greater than I1. Right? Which means V2 equals V1 and I2 is greater than I1. First one. Right? First one. First one. Take down if anything. Right? So when it comes to questions, our known theories are used in a creative manner. Right? When it comes to the question, they are used in a creative manner. That's the thing. To tackle the creativity, we have to have a solid knowledge. To tackle that creativity, that's the thing. We have to have a solid knowledge. Next. And yeah, that's the last for the day. That's the last for the day. Right. The circuit contains 75 ohms resistor and an unknown resistor are in the resistor box. Okay. Unknown resistor are in the resistor box. As shown in the diagram, the internal resistance of the battery is negligible. If the voltage across 75 ohms is 9 volts, which of the following represents the unknown resistor? Right. Now, this is a printing mistake. This 12 volts should be here. 12 volts is the EMF of the battery. 12 volts is the EMF of the battery. It should be here. Right. 12 volts. That is the EMF of the battery. Right. 12 volts. Now it says across this we have 9 volts now. Across this. Then from 12 volts, if 9 volts are across this, the remaining 3 volts should be here. Remaining 3 volts should be here. Right? Remaining 3 should be here. Now let's assume resistance of this one as R. Then we can use, there are two resistors in series combination, we can use potential divider again to find R. Right? To find R. Then I'm going to use potential divider for 75 ohms. See? For 75 ohms. Total is, now total potential difference across 75 is 9. Total is 12 over addition 9 plus 3 times 9. Sorry, 9 plus 3, sorry, 9 plus R. 9 plus R. Right? 9 plus R. Sorry, 9 75. 75 plus R. Okay. Resistors are 75 and R. Resistors are 75 and R. Then 12 over 75 plus R into 75. Right, my target is finding R. My target is finding R. Right. Now by 3 this cancels, no? By 3, 3 times 3, 3 times 4. Again by 25, by 3 this cancels, 25. Simplify. Then 75 plus R. 75 plus R equals 100. R equals 25 ohms. Then resistance of the resistor box should be 25. Resistance of the resistor box should be 25. Right? Now check the given answers. Resistance of the resistor box is 25. Right? In first one, 225 resistors are given. Right? 25 means 12.5. Wrong. Here, 25 is given with a conducting wire, that is going to be a short circuit. Right? Third one, 50-50. Parallel, equivalent is 25 ohms. So that is acceptable, that is correct. Right? Fourth one, 50 ohms, wrong. 75 ohms, wrong. So answer is 3. Answer is 3. 50-50 means 25. So we know resultant of the box as 25 from here. Right? So that is 25, answer 3. 25, answer 3. Right? Right? So with that, we have come to the end of the 25 questions I selected today, right? 25 questions selected today, right? Now, sooner in the S2A discussions, in these discussions, I'll be taking structured essays and essays also, right? Let's see, right? We have only 11 weeks left, right? So during the 11 weeks also, we'll be having these sessions, right? And sometimes the duration will be a little bit longer than this. Sometimes, let's see, right? I'll try to manage it to somewhere around 1 hour to 1.5 hours, right? But sometimes, let's see, with the questions, with the length of the questions and the number of questions we are going to discuss, sometimes it can go up to like 1 hour and 45 minutes or 1 hour and 50 minutes, something like that, right? Let's see. Right, any questions from these questions we discussed today? Any questions, anything to clarify from my side? Right. Then, if no questions, we can wind up the session for today, right? Right. All right. Then, if no questions, we'll wind up. If no questions, we'll wind up, right? You can get all the updates about the upcoming sessions through the channels, right? So I will decide what we are going to discuss in the next session, and we'll let you know, right? We'll let you know. Now the thing is, we are 11 weeks and 3 days from the exam. That's a very high time, and time flies these days, right? It's a very high time and it flies, right? Very high time. Just 11 weeks, right? Just 11 weeks, right? So when we are meeting next week, it will be 10 weeks, right? It flies. It flies away before you think. That's the thing. It flies away before you think, right? So without wasting your time, you have to utilize the time remaining here, right? That's the main thing in this time period. Stay safe and utilize it for all the studies to balance among 3 subjects. Okay, then, if no questions, we'll wind up, right? Then stay safe and work hard. We'll see you in the next class. Good night and goodbye.